Alright, 8th graders, welcome to Chapter 3, Lesson 2, Slope video. In this lesson, our objective is that we're going to use tables and graphs to find the slope of a line. So hopefully you guys are thinking about, what does that word mean? What does slope mean? So that's what we're going to discover in this lesson. We're going to find out slope of lines and slope of tables. So our standard is 8th grade equivalent expression, standard number 5. Let's go ahead and start. In this lesson, we have 3 vocab words. The first vocab word is slope. Slope is the steepness of a line. So if we have something really steep, it kind of looks like roller coasters. So steepness of a line, I always ask myself, would I be comfortable walking up it? If I don't feel like I'm comfortable walking up or down something because of the angle it is, then I'm saying that's really steep. But if I do feel comfortable, it's not too steep, it's alright. So we have 4 different types of slopes. We have a positive slope, and if we look at it from left to right, it goes up. We have a negative slope, and if we look at it from left to right, it goes down. We also have a slope that's called no slope, or a slope of 0. If you have a slope of 0, that means it's going 0 up, but it's going either right or left, so it's always a 0 over some number. So a no slope doesn't go up and it doesn't go down, it just goes straight across. And last slope that we have is something called undefined, and the reason why we call it undefined is because we don't know if it's going up or if it's going down, because it kind of looks like it's doing both. So we don't know what it is, so we call it undefined. Now if you have a slope that is undefined, that means you have a number being divided by 0. Now the top number is going to tell you how much to go up or down, and the bottom number is going to tell you how much to go right or left. So I would go up by some number, but I would not go over at all. I'd go up by some number, not go over any all, and I would see that when I connect my points, I make it a line that goes straight up and down. So that leads us into our next part, rise and run. There's 2 things that you need when looking at a slope. You need a rise, and you need a run. Slope is also called rise over run. Now the rise is the vertical change between any 2 points. So how much I go up from one point to another point, that's vertical change. Now if I go up, that's a positive, and if I go down, that's a negative. So I can have a rise that's negative, which means instead of going up, my graph goes down. I can have a rise that's positive, and my graph goes up. Now we can also have a run. Now a run is horizontal change. Horizontal change between any 2 points. So, if it's positive, positive numbers go right on the number line, and negative numbers go left on the number line. So, if we have a positive number, we move to the right, however many spaces the run tells us. And if it's a negative number, we move to the left, however many spaces it tells us. Now, I don't expect this to make complete sense right now, but we're going to be finding slope by finding the rise over the run in this lesson. So, I'm going to show you how to do that. So, pay attention. Remember that we're going to have positive slopes, negative slopes, no slopes, and undefined slopes in this lesson. Before we actually begin this lesson, we need to understand what slope is. So we have positive slopes which go up, we have negative slopes which go down, we have no slope, and undefined slope. Now, before we begin, there is one really important formula that we need to understand in mathematics, and that's this formula right here. So slope is how something changes vertical and horizontal at the same time to make the angle of a graph that we see. Now in mathematics, the variable m represents slope. So anytime you see an m in mathematics, unless it's labeled otherwise, it probably means something to deal with slope, the steepness of a line. Now the bigger the number, the steeper the line. The smaller the number, the less steep the line. So our slope is going to equal y2 minus y1 divided by x2 minus x1. Now, those letters might not make too much sense, but slope is how we find the vertical change from one point to another point, as well as the horizontal change. The vertical change is called our rise, and the horizontal change is called our run. So we're going to find the rise and run to go from one point to the next point. When we take our y2 coordinate and we subtract our y1 coordinate, we actually figure out the change in y, which is called the rise. Also kind of sounds like the rate of change. We also find the change in when we take x minus x1, or x2 minus x1, we find the change in x, rate of change. So slope is actually equal to the change in y divided by change in x. Rise over run. So what we're doing is we're actually using this formula to determine what slope is. What did the y change by? What did the x change by? How do I go from this point to that point? And if you don't have 2 points graphed on a line, you might want to put 2 points on a line. So then if you can find the coordinates, you write the coordinates down. And whenever you write your coordinates down, the best thing that you can do is you can always do this first. Anytime you're given 2 pairs of coordinates, you should label your coordinates. And you should label the first set as x1, y1 underneath the numbers, and then label the second set x2, y2 underneath the numbers, and that'll make the slope formula a little bit easier to apply, because the slope formula is when we take our y2 number minus our y1 number, our x2 number minus our x1 number. And we're actually going to apply that in this lesson. So let's look at our first example and see if we can find the slope between whatever's happening there. In our first example, we're going to find the slope of the ladder. So what angle is this going up at? Now to me, if I was walking or trying to run, that'd be a pretty steep slope. So we're going to find the slope of the ladder. Now I drew a nice little picture of a house and I drew a ladder. And we know that the ladder is 3 feet away from the house. So it's not too close to the house, but it's 3 feet away. It's also going 15 feet high to the top of the house. So the ladder is 3 feet away, going 15 feet high. So to find the slope, we're going to figure out how much vertical change we have and how much horizontal change we have, which is also called a rise and run. So we need to remember that slope is equal to our rise over our run. So if we wanted to figure out how the slope of this ladder is, we're going to figure out how much up does the ladder go first. And if we look at that, the ladder goes 15 feet up over how much horizontal change it has. Well, it has 3 feet of horizontal change. So it's 15 over 3. And if we take 15 divided by 3, we get 5 feet for every 1 foot. So for every 5 feet up the ladder stands, it goes 1 foot away from the house. And that's how we get this angle. Every time we go up 5 feet, we go out 1 foot away from the house. And this right here represents the slope of the ladder, 5 over 1. Let's go ahead and look at another problem that deals with slope. In our next example, we're looking at a word problem. It says the access ramp from the sidewalk to the door of a hotel rises 8 inches for every horizontal change of 96 inches. What is the slope of the ramp? Now, maybe we don't understand kind of what it's saying. So what we could always do is we could kind of draw a picture of kind of like what it's saying. So here's my hotel. And from the hotel, we're going to have a ramp that somebody is going to be able to walk up. So it can't be really steep because they're going to be able to walk up to get to the door of the hotel. So if they're walking up to get to the door of the hotel, we need to make sure that the ramp isn't too steep. Now, the ground is right here, right where the hotel starts at. So the ground's here, and they're trying to go up to the door of the hotel. So the door is a little bit higher because sometimes, usually in the bottom of a hotel, you might have your pool room and stuff like that. So the person's trying to walk up to the hotel. Now, what it says is it says for every 8 inches, so every time that I go up 8 inches, every time I go up 8 inches, it actually has a horizontal change of 96 inches. So if I wanted to figure out what this slope is, what that angle is, how steep that line is, what I need to do is I need to figure out its rise, which there's a word right there, rise. We're trying to find the slope. So we need to figure out the rise over the run, the vertical change over the horizontal change. It's going to rise 8 inches. So every time it goes up by 8 inches, it's going to have a run of 96 inches. So 8 inches doesn't seem like much going up, but it's 96 inches long. So Our horizontal change is 96. A rise is vertical change. So it's 8 inches over 96 inches. And we could simplify this down and we could say 96 and 8, they can divide by 2. So 98 divided by 2 is 4. And 96 divided by 2 would be 48. And we can divide those by 2. Actually, we can divide them by 4. So every time the ramp goes up 1 inch, it has 12 inches of run. So every time we move the ramp up by 1 inch, there's 12 inches in between that spot. So it takes 12 inches to go up 1 inch, 12 inches to go up 2 inches, another 12 inches to go up 3 inches. So 36 inches, 3 inches in rise. That's not very fast. But again, we need to think about safety, and we need to think about, is it logical that we can walk up something, or wheel a wheelchair up if we need to. So access ramps are very important, and we need to make sure that they don't go up too fast, or that way people can walk down and go up them at a safe manner. So our rise over run is 1 over 12. All right. In our next example, we're going to look at a graph, and our job is to find the slope of this line. So it says the graph shows the cost of muffins at a bake sale. Our job is to find the slope of the line. So we need to figure out how steep that line is. Now, to me, that looks pretty steep. I wouldn't feel comfortable running up it, so that is a positive slope because it's going up. And now we need to figure out what's its slope. So it's hard to determine what the slope is because we don't have anywhere to judge. So what we want to do first is anytime we see a graph, we want to plot 2 points on the line. We want to make sure that there's somewhere that we can actually see. So I'm looking here, and I see that the graph is right at 1 and 2. So for one muffin, it's $2. Okay, I'm looking here at 2, it's at 4. So at 2, it's at 4, right there. So at 2 muffins, it's at $4. And at 3 muffins, it's at $6. So 3 and 6. Okay, so I plot 3 points on the line. So this point right here is 3 muffins, $6. This one is 2 muffins, $4. And this one is 1 muffin, $2. So I want to find the slope, and all I only need is 2 points, but I put 3 points on here, and I could probably put a 4th point on here, and I go up here, and there it is. It's at 4 and 8. All right. So you can put as many points as you want on a line, but you only need 2 to find the slope. So to find the slope, what we're going to do is we're going to figure out the rise, and then we're going to figure out the run, because slope is equal to our rise over our run. So what we need to do is say, how much do I go up from this point to this point here? Well, if I look, I'm going from 4 to 6. So I'm rising by 2. Now I want to say, how much do I go over from right here to there? So I look, I'm going from 2 to 3. So I'm going over by 1. So my rise over my run is 2 over 1. Now if I look at this, it says that the total cost, which is money, so this is the cost, and down here it says muffins. So what this slope tells me is this slope tells me that it costs $2 for 1 muffin. What we did was we said, how much do I go up? How much do I go over? Now the cool thing about this is you can do this every time. If I went from this point to that point, I would go up 2 and over 1. And 2 over 1 is still $2 for 1. And if you really, really, really want to get fancy, you could pick a point that is really far away. Say I wanted to say, what's the slope from this point all the way to that point? So how much do I go up from here all the way up to this point here? So I'm going from 2 all the way up to 8. Well, 2 to 8 is a rise of 6. And then how much do I go over from 1 to 4? So I'm going from 1 to 4. 1 to 4. So that's a rise of 6 and a run of 3. And you might be saying, that's a different slope. But 6 divided by 3 equals 2, and we can always put a 1 under it to make that a fraction. So this means that it's still a slope of $2 for one muffin. So, as long as everything falls on a straight line, your slope is going to be the same no matter how far away your points are. You pick 2 points, you find the rise, you find the run, you write it as a fraction, and then simplify your fraction down, and you'll have the same answer. If you pick 2 close points, you'll get your rise and run, and maybe it'll be in simplified form already. So anytime that you have a graph, plot 2 points, and then find the rise, find the run. So tell me how much it goes up, how much it goes over. Make sure you can write the coordinates of those points down, so that way you can actually get exact numbers, and that's how you find the slope of the line. So this slope is for every $2, you get 1 muffin. In our third example, we're going to look at a table and find the slope of a table. It says the table shows the number of pages that Garrett has left to read after a certain number of minutes. The points lie on a line, so they're telling us this, if we were to graph it, makes a line. We need to find the slope of the line. So since we know that this makes a line, if you think about the previous lesson, we know that it's going to have a constant rate of change. So what we're going to do is we're going to find the slope. Well, the slope is the rise over the run, or the vertical change over the horizontal change, or the change in y over the change in x. So we're going to find the slope. And since we know that these points make a straight line, we can pick any 2 points out of the table. So I'm going to go ahead and pick 5, 6, and 1, 12. And it doesn't matter what points we pick, because our slope is always going to be the same because they lie on a line. Since they're on a line, we can find the slope. So what we're going to do is we're going to figure out what's happening with this slope. So first thing we do is we find the change in the y, because that's the vertical change. So the y side is on the right. It's going from 12 to 6. So the slope on the y side is changing by 6. And now we got to find the change in x. Well, it's changing from 1 to 5. So 1 to 5 is a change of 4. And we could have done this the same way we did previously. This went up by 4, and this went down by 6. So if you think about the previous lesson, we kind of did this. We drew an arrow, and we said how much did it go up or down by. We can still do that between the 2 points that we picked. This right here represents our slope. And notice that there's a negative and a positive. Well, negative divided by a positive is a negative. So that means that this graph would be going down because it has a negative slope. Now, I can go ahead and simplify this. 6 and 4 divide by 2, so this is a negative 3 over 4 divided by 2 is 2. So that means that he goes down 3 pages every 2 minutes. So the amount of pages that Garrett has left to read is getting smaller by 3 pages every 2 minutes. And if I was to graph this, if I had a point, my slope is a negative 3, so I start at this point and say that was where that negative 3 is, or wherever I'm starting. I'm going to go down 3, 1, 2, 3. I'm going to go over 2, 1, 2, and put a dot, and my slope would look something like this, which, as we can see, the slope is going down. So this is a negative slope, and we see the negative sign there. Makes sense that it's a negative slope. We're going to do one more problem. We're going to find the slope between 2 points. For our final example, we're going to find the slope from R to S. It says we're going to find the slope of a line that passes through these points. So it's a slope of a line, so it's going to be doing something. And we got to figure out what's happening with this line. Well, in this case, since we're given 2 points, this is where we're going to label our points. X1, Y1, X2, Y2. This is the first pair. This is the second pair. And since we're finding the slope between 2 points, we could graph them and then figure out the rise and run, but in this case, we're going to do it algebraically. So we're going to use our formula for slope. Slope is equal to the variable m. And m is always equal to y2 minus y1 over x2 minus x1. And the reason why it's important to put a label on those is because now that you see these variables, you can actually replace those variables with what they are. So we're going to go ahead and do that. We're going to say that our slope, or our variable m, is going to equal our y2, which is 3, minus the y1, which is 2, over, or divided by, the x2, which is negative 4, minus the x1, which is 1. So this is what we got to figure out what our slope is. 3 minus 2, that's 1. Negative 4 minus 1 more is negative 5. So this right here is our slope. That means to go from one point to the other point, I would go up 1, but I'd go back by 5. Or I could go down 1 and right by 5 to get to that point. And since this has a negative sign, it would look something like this. If I start with a point here, I could go down 1, 1, 2, 3, 4, 5 over. And my slope would be something like this. Now this slope is still the same. If I started at this point, I could go up 1 and back 5, and I'd be right back at that same point. So this is my rise over run, this is my rise over run, and they're exactly equal. It doesn't matter if your negative's on bottom or if your negative's on top, but in this case, we had a negative on bottom based on our slope rule. So this is our slope. It looks something like that. That's it for today's lesson. Hopefully you guys understand this. We're going to be practicing in class a lot of problems to practice and make sure that we really do understand how to find slope. We're going to find slope between 2 points. We're going to find slope on tables. We're going to find slope on graphs. And we're going to find slopes with story problems. That's our lesson, and I will see you tomorrow.